Hello, welcome back, POE kids. Today we've got, should be a relatively short PowerPoint presentation on statics. All right. So statics is basically the study of the forces and their effects on a system in a state of rest or uniform motion. So basically, it's the study of nothing changing, of everything staying still. And that's pretty useful because there's a lot of things we'd like to stay still. We'd like bridges to stay put and stay still. We'd like, here's an example of some scaffolding holding up some lights. We want that to stay still. Here's some materials in a dock. We want all this material to stay put. We like buildings to stay put. And so this is may seem trivial, but it's actually very, very important. Okay, and it's all based on Newton's laws of motion, basically. So Newton's first law of motion is that an object in a state of rest or uniform motion will continue to do so unless unless acted upon by an outside force. And really, unless acted on by an outside net force is how that should be worded, because forces can cancel out. Okay, and if forces cancel out, it's like there's no force. Okay? Newton's second law of motion, and the previous one was pretty much the big one. Forces have to cancel out is basically how statics work. Forces have got to cancel. Newton's second law of motion, which we don't really want to be happening, but the acceleration of an object is proportional to the net force acting on the object and inversely proportional to an object's mass. So basically, the harder you push something, the more it accelerates, and the more mass an object has, the more it resists acceleration. Okay. All right, Newton's third law of motion. For every action, there's an equal and opposite reaction force. And so when you touch the wall touches you back. That kind of, okay? So static equilibrium is when there's no net external forces. So the net force on this object is zero. So we want this oil rig here out in the ocean to be motionless. That means all the forces must cancel. Okay? So there's no net external forces acting upon the object, and the body remains at rest or continues at a constant velocity. We're only concerned with remaining at rest. Okay. Translational equilibrium is one of the situations that we're going to have to consider here. The sum of the forces in the x direction have to equal zero. This is a way of mathematically stating that the left forces have to balance out with the right forces. Okay, so when I add up my left and my right forces, they should cancel out and become zero. Okay, this force is in the y direction, so now we're talking about up and down. Okay, so this is a way of saying that when I add up my up forces and my down forces, they should also add to zero, meaning that they cancel out. Okay, so here we've got balance forces. Okay, and here we've got a disaster going on, and we had some unbalanced forces acting on in that case. Okay, what also has to happen is, okay, my ups and downs have to cancel, my left and right forces have to cancel, my torques also have to cancel, and if my torques don't cancel, then that's bad. Okay, we get crashing. So they're stating it as the sum of m equals zero. POE likes to use the term moment and moments. I'm used to using the term torque. They're identical. They mean the same thing. And so what we're saying here is that my torques clockwise, okay, have to balance out with my torques counterclockwise, okay, and everything has to cancel out. Okay. If you took honors topics in physics last year, we talked about torques and torques canceling and that sort of thing. So you've got a leg up. Okay. So there are two types of quantities that we deal with: scalar quantities Scalar quantities only have a number. They do not have a direction. Okay. So temperature is a scalar quantity. It does not have a direction. So mass, length can be a direction, but I guess not as length. Volume is a good one that doesn't have a direction. Temperature, pressure, and speed. Then there are vector quantities. Vector quantities have both a magnitude and a direction. Okay, you should know these terms from physics from freshman year. And so velocity is a big one that has a direction. Force also is going to be a big one in this unit that also has a direction, either up, down, left, or right, or at some angle. And moment or torque is also going to be a big one in this unit, either clockwise or counterclockwise. Okay. So I'm not really quite sure why they put this in here, but it fits well enough. So a vector quantity is known by its magnitude, its direction, and point of application. Okay. So basically, this is the magnitude, the 45 pounds of force. The direction is given by 21.8 degrees north of east. Okay. And the point of application in this case is the origin of the graph. Okay. So some units that we're going to deal with when we talk about force. There's pound force, which is what we use in American engineers quite a bit. There's also newtons, which is used by most people. Here's how to convert between them. 1 pound force is equal to 4.448 newtons. Okay. And this is something that also, if you took honors topics in physics, we've done this in that class. Basically, what they're saying here is that you can take a diagonal force vector, okay, and you can break it up into its component vectors. Remember, getting out your rulers and protractors and doing all this stuff. So we can take this diagonal vector and we can replace it by a vertical component and a horizontal component, and that's important in this unit that we do that because again, it's the ups and downs have to cancel, and the lefts and the rights have to cancel. So that's why that's important. Okay. So the resultant force is the sum of the forces that you get. So if you have 5 pounds to the right and 2 pounds to the right, the resultant is 7 pounds to the right. In statics, we want the resultant to be 0. So in this case, we've got 5 to the right and 2 to the left. Okay, because they're in opposite directions, they're going to cancel out, or at least partially cancel out. And so we're going to end up with 3 pounds to the right. Okay, had this been 5 pounds to the left, and we'd have had 5 pounds to the right and 5 pounds to the left, the resultant would have been 0, and we would have had a static object. Okay, that is that for today. Enjoy your day.